What is time? Time is an ever-present concept that has intrigued humans for millennia, shaping our understanding of the universe and our place within it. But what exactly is time? What is it? And how have our perceptions of it evolved through the ages? Time, in its simplest form, is the continued sequence of existence and events that occur in an apparently irreversible succession from the past through the present to the future. It is a fundamental aspect of the universe or multiverse, intricately woven into the fabric of reality or the real world. The concept or idea of time measurement dates back over 5,000 years to ancient civilizations like the Sumerians and Egyptians, who used primitive sundials and famous water clocks to track the passage of time. In the Western tradition, prominent Greek philosophers, including Heraclitus and Aristotle, contributed significantly to early ideas about time. Heraclitus viewed time as a constant flow, while Aristotle defined time as a number of change with respect to the before and after. However, the scientific count of time, as we understand it today, started with the Gregorian calendar in 1582, which refined earlier systems to better match the Earth's orbit around the Sun. Julian calendar. Introduced by Julius Caesar in 46 BCE, the Julian calendar was a significant advancement, standardizing time measurement across the Roman Empire and Gregorian calendar. In 1582, Pope Gregory XIII introduced the Gregorian calendar, refining the Julian system to better align with the Earth's orbit around the Sun. This calendar remains in use today. Time is defined through its measurement: seconds, minutes, hours, days, years, using clocks and calendars. These tools help us quantify the passage of time, allowing us to organize our lives and understand the natural world. Now, if we want to say something about the birth of modern timekeeping, then first we need to tell about mechanical clocks. The invention of mechanical clocks in the 14th century revolutionized timekeeping, providing more accurate and consistent measurement of hours and minutes. Another one is pendulum clocks. In 1656, Dutch scientist Christian Huygens invented the pendulum clock, significantly improving accuracy. Finally, the invention of British physicist's atomic clock, developed in the mid-20th century, measures time based on the vibrations of atoms, providing unparalleled accuracy. These clocks are crucial for technologies like GPS and global communications. When did time start in the universe? What is the scientific revolution of time? What are the theories of time? Well, let's dive in. The concept of time, as we understand it, originally began with the Big Bang, approximately 13.8 billion years ago. This monumental event marked the beginning of the universe and the start of the flow of time. Prior to the Big Bang, the laws of physics, including the dimension of time as we understand them, did not apply. British scientist Sir Isaac Newton's physics, which is called Newtonian physics, described time as absolute and universal, flowing at a constant rate regardless of the observer's state of motion. On the other hand, Albert Einstein's theories of relativity, developed in the early 20th century, revolutionized our understanding of time. In his special theory of relativity in 1905, Einstein proposed that time is relative, varying with the observer's velocity. Namely, time is not absolute. It can vary depending on the speed at which an object is moving and the presence of gravitational fields. This means that time can dilate or stretch, making it possible for two observers to experience different durations for the same event. His general theory of relativity in 1915 further showed that gravity can warp space-time, affecting the flow of time. In physics, time is a dimension in which events occur in a linear sequence. It is one of the 4 dimensions of space-time, alongside the 3 spatial dimensions. This understanding is crucial for the theories of relativity and quantum mechanics. So, in the realm of quantum mechanics, Time plays a crucial role in the behavior of particles at the smallest scales. However, the integration of time with quantum theory remains an ongoing challenge in theoretical physics. And modern physics views time as the fourth dimension, integral to the space-time continuum. This concept is essential for understanding phenomena such as black holes and the expansion of the universe. Contemporary theories and debates. What is the theory of time? The theory of time encompasses various scientific and philosophical perspectives on its nature and behavior. In physics, the most influential theory is Einstein's theory of relativity, which includes both the special and general theories. These theories describe how time is not absolute but relative and can be affected by speed and gravity. First, arrow of time. The concept of the arrow of time, proposed by Arthur Eddington in 1927, describes the one-way direction or asymmetry of time, driven by the second law of thermodynamics and the increase of entropy. Second, time illusion. Some physicists and philosophers argue that time is an illusion, a construct of human consciousness. This debate touches on deep questions about the nature of reality and our perception of it. Third, Big Bang theory. The current scientific consensus holds that time began with the Big Bang approximately 13.8 billion years ago. The Big Bang marked the start of the universe and the flow of time. Fourth, cosmic time cosmologists study the evolution of the universe over cosmic timescales, exploring how time influences the formation and development of galaxies, stars, and planetary systems. Fifth, unifying theories. Scientists continue to seek a unified theory that reconciles general relativity and quantum mechanics, potentially providing a deeper understanding of time. Sixth, time travel. While time travel remains a popular topic in science fiction, theoretical physicists explore the possibilities and constraints within the framework of known physical laws. According to the above statement, we can say, the history of time is a journey from ancient observations and philosophical musings to the cutting-edge scientific theories that shape our current understanding. Time remains one of the most intriguing and fundamental aspects of the universe, central to both our daily lives and the profound mysteries of existence. Now we will try to know the time through some questions, or try to answer some questions. By answering the questions, we will try to know more about time question number 1. Who and when invented the theory of time? The modern scientific theory of time was primarily developed by Albert Einstein in the early 20th century. His special theory of relativity, introduced in 1905, revolutionized the concept of time by showing that it is relative to the observer's frame of reference. His general theory of relativity, published in 1915, further expanded this by describing how gravity can warp space-time. Question number 2, is time a human construct? While our methods of measuring and conceptualizing time are human constructs, the phenomenon of time itself exists independently of human perception. Our constructs help us make sense of and navigate the natural progression of events. Question number 3, is time involved in every event in the universe? Yes, time is involved in every event in the universe. It is the framework within which all physical processes occur. From the motion of galaxies to the interactions of subatomic particles, every change, movement, and interaction in the universe is governed by the passage of time. Question number 4, what happens if time doesn't exist? If time didn't exist, there would be no progression of events. Everything would happen simultaneously, making the concept of cause and effect meaningless. The universe, as we understand it, relies on the passage of time to function. Question number 5, is time real or a theory? Time is both real and theoretical. It is real in the sense that it governs the sequence of events in our universe, but our understanding of its nature is framed by theoretical physics, particularly Einstein's theory of relativity and modern quantum theories. Question number 6, what is the time formula in physics? In physics, time is often denoted by T and is a key variable in many equations. One of the most famous formulas involving time is the kinematic equation, distance traveled with respect to time. where s is displacement, u is initial velocity, a is acceleration, and t is time. Question number 7. What is time illusion? The time illusion refers to the subjective experience of time, which can vary greatly depending on circumstances. For example, time may seem to fly during enjoyable activities and drag during boring ones. This perception highlights that while physical time is constant, psychological time is flexible. Question number 8. Why is time an illusion? Time is considered an illusion because our perception of it can be manipulated by various factors, including speed, gravity, and even our mental state. While the physical passage of time is consistent, our experience of it can be quite different. Question number 9. Will time ever stop, or if time stops, what will happen to the universe? Current scientific understanding suggests that time, as an integral dimension of the universe, is unlikely to stop. However, hypothetically, if time were to stop, all motion and change in the universe would cease. Processes dependent on the passage of time, from the orbits of planets to biochemical reactions in living organisms, would halt, rendering the universe static and unchanging. Question number 10. What is the modern scientific theory of time? Modern science views time through the lens of relativity and quantum mechanics. Relativity shows that time is intertwined with space and affected by gravity and speed, while quantum mechanics explores time's role at the smallest scales of the universe. Question number 11. What does science say about time? Science acknowledges time as a fundamental component of the universe, essential for the structure of reality. It is both a dimension and a measurable quantity, intricately linked to space and influenced by physical laws. Question number 12. Is it possible to bend time like light bends around a black hole? The concept of bending time, much like light bends around a black hole, is a fascinating topic in theoretical physics, particularly within the framework of Einstein's theory of general relativity. Here, we explore how time can be bent or altered and the implications of this phenomenon. Question number 13. What is the nature of time and space-time? Time, in the context of physics, is one of the dimensions in the four-dimensional fabric known as space-time. Space-time is the fusion of the three spatial dimensions and one time dimension, creating a continuum that can be warped by gravity. Question number 14. What is the general relativity and space-time warping? Albert Einstein's general theory of relativity, published in 1915, fundamentally changed our understanding of gravity. Theory of general relativity says that mass and energy warp spacetime, namely massive objects such as stars and black holes, cause a distortion in the spacetime around them. This warping affects the paths that objects, including light, take through space. Question number 15. What is gravitational time dilation? As spacetime is warped by massive objects, time itself is affected. Clocks closer to a massive object tick more slowly compared to those further away. This phenomenon is known as gravitational time dilation. Question number 16. What is event horizon? The boundary around a black hole beyond which nothing can escape, including light. Near this region, the warping of spacetime becomes incredibly intense. Question number 17. What is time dilation? Near the event horizon of a black hole, the warping of space-time is so extreme that time effectively slows down relative to an observer far away. This means that an object approaching the event horizon would appear to freeze in time to a distant observer, though from the object's perspective, time would continue normally. Question number 18. Can we bend time? While bending time in a literal sense, like bending a physical object, is not possible, we can influence the passage of time through gravitational fields. Number 1. Gravitational fields. Strong gravitational fields, such as those near black holes or neutron stars, can significantly slow down time. This is a form of bending time, as the flow of time is altered by the gravitational influence of massive objects. Number 2. Moving at high speeds. According to special relativity, time also dilates, slows down, for objects moving at speeds close to the speed of light relative to an observer. This is another way in which the passage of time can be manipulated. Practical implications. Number 3. GPS systems. The satellites in the Global Positioning System, GPS, must account for both gravitational time dilation, due to the Earth's gravity, and the effects of their high speeds. Without these corrections, the system would quickly become inaccurate. Number 4, experimental confirmation. Experiments using atomic clocks on airplanes and satellites have confirmed the predictions of time dilation due to both gravity and high velocities, validating Einstein's theories. Question number 19. What is the theoretical explorations of time? Number 1, wormholes. Theoretical constructs called wormholes or Einstein-Rosen bridges propose shortcuts through space-time. If such structures exist, they might allow for connections between distant points in space-time, potentially enabling time travel. However, these remain speculative and unproven. Number 2, time machine. Some solutions to the equations of general relativity suggest the possibility of closed time-like curves, which could theoretically allow for time travel to the past. These solutions often involve exotic matter with negative energy density, which has not been observed. While we cannot bend time in the same way we think of bending physical objects, we can alter its passage through the warping effects of gravity and high velocities. These effects are well documented and have practical applications, such as in GPS technology. The extreme warping of space-time near black holes provides a dramatic illustration of how massive objects can influence time, continuing to inspire scientific exploration and theoretical research into the nature of time and the universe. In conclusion, time is a multifaceted and intriguing phenomenon that continues to challenge and inspire scientists and philosophers alike. From ancient sundials to atomic clocks, our journey to understand time reflects humanity's quest to comprehend the very nature of existence. Time? It's the invisible thread that weaves together the fabric of our existence, from the ticking seconds that count down our daily lives to the vast eons that shape the universe. Time is both our greatest ally and our most formidable adversary. Imagine a world where we could harness the full potential of time, where every moment counts and the mysteries of the past, present and future are within our grasp. In this long journey, we have tried to unravel the enigmatic nature of time. We have tried to delve into the science of time travel, explore the concept of space-time, and question whether we can ever truly master the fourth dimension. This is more than just a video. It's a quest to understand the essence of our reality. But we need you, yes, you. Your curiosity, your questions, and your passion for knowledge are the keys to unlocking the secrets of time. Join us, and together we can turn every second into an opportunity for discovery and wonder. Subscribe, hit the bell icon, and be part of a community that dares to challenge the limits of time itself. Because in the end, time is not just what we measure, it's what we make of it.